Sorry, guys. Hey, guys, it's Tarek with Cyclone FPV, and I'm getting ready to do a thrust test, a benchmark on some motors and some props. We've got a big, extensive database we're building right now, and I'm going to show you how this is going to work. Now, I've done this in the past, but I've changed the setup a little bit, and so I'm going to kind of show you how this is going to work a little bit, okay? We're going to use our first test as an example. So let me show you what I've got here, and I'll put in a picture-in-picture here. Let me see if I can fix that up there, and that should somewhat work. Okay, so there you go. So obviously you can tell I'm on a Mac, and I'll see if I can get this bar. I may just auto hide this bar. There we go. All right, so let's make this full screen. Okay, so on this side we have the RC Benchmark software running with their thrust, their bench tester right here. Their let me see, this is the 1585. Let me check and make sure set up. Let me see, it's not the 1520, it is the 1585, right? Okay, so we get a lot of data from this. Now, I've already done my calibration. I did it 6 days ago, got all these done 6 days ago. And here's what we're gonna do. We're putting in the description of what we're testing first, right? So the test is gonna be running a Chaos 2207.5. Let me see this real quick. Oh, I wonder, you know what? Let me see what this says. I'm curious to see. I just noticed this. Okay, so we're setting up the Chaos 2207.5, 2108 kV motors. The T-motor, we're using a T-motor 45 amp, and we're using the GemFan 51 466 3-blade props and a Sugar Rush 4S battery. Okay, so anyways, I'm sorry I'm starting through all this. I am trying to also do a couple things here on the side while we get ready to run this. So here's what's going to happen. The camera that you see this up here in the corner, in the top right corner is the prop on the machine. And I will tell you that in the first run, it actually blew the camera over because the air is pushing out, right? So I'm hopefully now going to be able to run this properly. And what you're going to see here is we're going to take we're going to get a lot of data from this. Now you can watch the screen here. You can see the current voltage that we're running. So we're running at 16.8. It'll still give you an idea. And the way this test is going to work is, let me see if I can get this to work here. I cannot get this. There we go. All right. So here's how this is going to work. So I'm going to run this test in intervals of 50, starting from 1050 all the way up to 1850. It's going to run for 4 seconds. It's going to take a reading at each second. Now, some of those numbers are going to be insignificant to you, but for me, the idea is I need to find the sweet spot of each motor given 3 different scenarios, 4, 5, and 6S, and given 10 different props. Now, here's the bag of props. Here's the bin of props. There's 10 different props from GemFan alone that I'm going to be testing. This just happens to be the first one, okay? So I'm going to run all these through, and I need to find the sweet spots. I need to see where the thrust is, where the sweet spot is for the thrust and the best efficiency and so forth. So that's why I'm doing it in increments of 50. If I find that the data isn't giving me enough feedback, then I'll adjust it. But right now, it's going to be a long test because you got to figure it's 4 seconds per run, and it's going to be 1050, 11, 1150, 12, 1250, 13, 1350, 14, 1450, 15, 1550, 16, 1650, 17, 1750, 18, 1850. So you're talking about 18 different runs, I believe, if that's what I just did. And so if that's the case, let's see. Let me see if I got this right. If that's right, 18 4 means this is going to be about a minute. It's going to run for quite a while, a little over almost a minute and a half. Okay, so let's just see what happens, and I'll keep you posted. Sorry about all the camera setup. I'm just rearranging right now, so I'm kind of making do with what I got. But the information here is going to be important. I'm going to put a whole video series together on why it's important and what it means to take a quad with this information and build the best racing quad, the best freestyle quad, the best quad for imaging and for hovering and long flight. All this information is going to help get us to that point. All right, so let me get you back to that screen there. Here we go. And as you can see here, what I've already got the script written, and it's right here. And what I want to do is I'm just going to run this real quick. I just want to make sure that we're reading a positive thrust, and we are. Okay, and then let me go back to our setup here, and I believe that our torque, let me do this. Let me go back to manual control. Yeah, so we have our torque now with, it should be a positive number, I believe. Let me just see, I'm not sure. Let me tear these again and go to manual and just see where we're at. Yeah, okay, we're good. All right, so we're gonna get, now you can see the thrust jumping around here, and this is just because, you know, we've got air, I mean, it's gonna move just because of air movement, air pressure, and things like that, but we should be ready to go. So here goes. This is what it's gonna look like, and then I'm gonna open the Excel file for you and show you what we're working with. Ready? It is gonna get loud, guys, so please be very careful. Keep your volume low. That's my warning to you right now. And as soon as I go over here to automatic control and I click run, start, you'll hear it initialize. We can look at thrust, RPM, ESC, temperature. I mean, we can look at all that stuff, I guess. if we want to right now. It's a lot to fit on this grid. So I'll tell you what, let's just do, forget temperature and ESC power. Let's just do thrust, but you can also see all the information here. And RPM I'm not worried about. All right, so here we go. Ready? Get ready. Okay, so it's starting quiet. It's only running at 1050. Now it's going to go to 1100. Now you can see the grams increasing. Soon I won't be able to talk over the noise. You can see the grams increasing here. I'm just going to be watching this camera to make sure it doesn't get blown over. Okay, we're at 98 grams. All right, 1300. 1350. Okay, and there you go. So what you see is you saw the whole setup climb up. Now you're going to see our voltage kind of recover here, right? So what matters now is I'm going to click return here, and I'm going to now go and see if I can show you. Let me minimize this, and let's go to our Finder window real quick. Let's go to our Dropbox, and then what we want to do is we want to go to our motor thrust data right here. And what you're going to see right here, I should make a shortcut to this on the desktop. That would be easier. Oops, no, cancel. My bad. Okay, so let's see right here, and then we've got. We are going to look at today's, and we're going to do it by date modified. So that would be today 225, which is this one. So I'm going to go ahead and open that up in Excel. Give it a second. It's going to take just a little bit. I got it. Oh, come on. Okay, so let's, well, okay, there we go. All right, now the data needs to be fixed a little bit. Okay, so the first thing is we have quite a few areas here that we don't need. These servo areas are blank, so we're going to delete these, and I'll update this to where it doesn't have to do that anymore. So this is going to be our ESC signal. So this is, I guess we would call this, let's just say, throttle. Oops, I'm typing in the wrong screen here. My apologies. Let me flip back over. Okay, so we're going to call this throttle. Okay, this way everybody can understand what this column is for. All right, so there's our throttle, and let me see what else we have. Let's see. We've got our torque here. Oh yeah, we do get a good torque reading here. So we have our thrust here. Now I'm going to change this so that we can get it down to just a few. Is it this way? No, it's going to be, no, whoa, wrong button, my bad. Let me undo this, undo that. I meant to go over here and go this way, Holy crap. I'll give it 2 digits past, and we will center this information. Okay, all right. So this is our battery voltage right here, and again, I will give this one 2 digits as well. And obviously when we present the data to you, normally this will already be done. I'm just kind of showing you what it's going to entail. Center that one. And our current as well will give you 2 digits. Okay. There we go. All right, this is going to be the RPM here. We're not running an optical right now, so I'm going to delete that column. Okay, so this is going to be called RPM motor. RPM, and we'll just put an E for electric instead of optical. So let's center that one. And then we have our watts used here. We'll leave that one alone for now, but just, again, we'll decrease it to just 2 numbers past the decimal for now. Let's see, what do we have here? Okay, watts mechanical power. Let me go ahead and do that one. All right. I know this is not fun to watch, I guess, and a little bit of, but I want you to understand what it is, all the data that goes through, and then I'm going to come back through later and give you a video on, to explain every single one of these columns. But right now what we're looking for is we're going to look for our thrust numbers. We're going to look for our overall efficiency, which is right here. So I'm going to shorten these up. So mechanical power, and we'll put watts. And then we'll do, this way we can shrink everything on here. Motor efficiency, and then we'll do a percentage. Okay, we'll shrink that one down. And then we'll do prop efficiency. Actually, I'm gonna leave this one like it is. I need to adjust this column later, but let me just do this for now. And we'll center all of these. Okay, and then this is what matters to me right here. I want to see the overall efficiency of this motor, and that way we're going to be able to compare this, and I'll give you data on what this means when we go through an explanation on that. So we'll do overall efficiency, we'll hit it like that, shrink these in, center them. All right, and we do have the issue with vibration that's really important, and this one I am going to leave right now for the time being, and then this is let me delete this, and this is the temperature of the ESC, not the motor. I will put the motor temp on here eventually, just right now I didn't feel like messing with it. All right, so of all the things that we're dealing with, these are the columns, and I'm going to bold these, I'm going to center them, and make sure they stay centered, and then this tells you where your throttle is, okay? Oh wait, no, well, crap. So this should have been, I wrote throttle in the wrong spot, now I see that. Yeah, I must have been like, dude, seriously. Let's do this. Throttle. Okay, so here's what I want you to notice. What matters to me is the following. These are insignificant right now. These columns won't matter for us. What matters to me is how much thrust we're getting, and this is what you need to know in order to know what it takes to hover your quad. So on a 4S with a 2108 kV motor, it's going to take you to 40% throttle to bring each motor to 218 grams of thrust. So if you were to look at that and say that your quad, let's say your quad, and I have a whole table I wrote on this, but let's just say your quad weighs 400 grams, okay? So to keep that quad hovering, I need 400 grams to balance it out, to make it even, right? Now, a racing quad usually has, let's just say, I mean, we can get them up into 15s to 1 range or more, but we need a ratio, and the ratio, let's just say, is going to be 8 to 1. That means that on a quad that weighs 400 grams, we need to have 3,200 grams of thrust, right? And I'm typing this in these cells, which really isn't going to matter much, but we need to have 3,200 grams of thrust, okay, to at some point in our race, and it needs to be when we're pulling in enough amps to where we can calculate, okay, based on these amps, multiply these times 4 because you're only running one motor, right? So then you put that into your calculation to figure out how much time, milliamps you've got in your battery, how long you're going to run, right? And I'll show you all that later. So what matters to me here is if I wanted to race this quad, I would need 3,200 grams of thrust. Well, to get that, divide the 3,200 grams by 4, and that means I'm going to need 800 grams of thrust per motor. Well, this motor is not going to achieve 800 grams of thrust on a 4S with this prop. It's not possible. At 1,850, now maybe at 1,000 it would, or 2,000 I mean, but it would not be efficient at that point. I'm already burning 14 amps, so this means that, you know, I mean, definitely I could run a 20 amp ESC on this thing, but also what it means is I'm not really getting it to be very efficient. You can tell by these low efficiency numbers right here. It's not very efficient. So anyways, so if you wanted to know how good this motor ran on a 4S, you could look right here and you could say, well, that kind of sucks because I'm not getting anything. Now, watch what happens when I run this same motor on a 5S. All right, so I'm going to take the 4S out. I'm going to save this, and I'm going to actually save it as, I don't know if I can save this as a file name, but I'm going to save. And I wish I could, so let me, oops. Oh, let me do it. Okay, so now what we're going to do is we're going to go back and we're going to run this again. So I'm going to go get a fully charged 5S. Which is right here. All right. So I got the 5S. Now look, here's the deal. I'm not going to take this to 6S, only because I know this motor is not going to handle 6S very well. But here's a 5S, okay? And you can look right here on your screen and you can see right now that we have 20.98 volts, okay? So I'm going to clear the Thrust and weight. I'm going to make sure we got a good run here. Okay, we do. All right. So now what I'm going to do is I'm going to go to automatic control, clear this again. I'm going to click run. And again, get ready. It's going to get a little loud. So here we go. Watch this area if you can. Okay, so look at that. We really pushed this quite a bit, and it's gonna all come back down here. So now what I'm gonna do is I'm gonna go back now to our, let's minimize, let's get this out of the way a little bit, and go back to our file. And now you're gonna see the new one right here. And I have to change the data here because this one says it's gonna be a 4S, and this was actually a 5S. So let's go ahead and update this. So this is gonna be a 5S 1500, all right? So I'm gonna click save on that first. Now, I'm going to delete this again, but what I'm going to do different here is I'm going to try, now this will take a little bit of work, obviously you would see it completed, but what I want to do is you will be able to see the following. So let me take this title, and let me copy that, and then let me close this. I want to save it, and then I'm going to go here, and I'm going to rename this, and I'm going to rename it this one, okay? So let's paste that. All right, so there we go. So now we have a 5S, and we have a 4S piece of data, right? So I'm gonna just, for now, I'm just gonna cut this here. I'm gonna copy it, and I'm gonna go over here, and I'm gonna paste it, okay? All right, now I will have these exactly under each other without any issues, but for right now, we're just gonna, work with me to kind of look at this here. First thing is I wanna take my columns here, and I wanna make a match, so let me copy, and let me paste here, okay? And then let's center them and bold them. And then what I'd like to do here is I'm gonna go ahead and take these down to 2, just like we did before. And I'm gonna take this one down here to 2, just like I did before. There we go. Now what am I missing? I'm not sure why I didn't get an electrical power reading on this one. So I'll have to see what I'm missing here. I think I've got a column missing. See, voltage, current, motor. Oh yeah, this one. Let's delete that. Oh, whoops. Sorry, my bad. Need to get this one out. So let me delete this. And we'll shift the cells over. There. So this should be a little bit better now. And I will bold this one. I thought I already did that, but I guess it didn't save it, whatever it may be. So we should be able to now see, oh yeah, we need to bring this back in. And let's do copy. I'm not sure why this changed, but paste. There we go. Okay, so now what we want, hey dude, so now what we want to do, you can come out here, Ashton, I'm just finishing a video up. All right, so now what we want to do is, we're going to leave the vibration where it is. Actually, I guess I changed it already, so let me just go ahead and move that in. Oh. Hey, I love you too, bud. I'll see you in a minute. Sorry, guys. I know I'm screwing this up, but you can stop watching at this point if you'd like. I get it. Why is it not going? There we go. All right, let's leave that. and then we'll leave this like it is for now. All right. Let me see what this is. Okay. Perfect. All right. So looking at these numbers, right? What did I do here? Did I shrink this down? I did. All right. So I'm just going to go ahead and copy these for right now. I'll edit it all later. God darn it. There. Okay, so let's compare, right? So this is the first motor. That's the first one we did. And this is the second motor. Okay, I mean the second battery. So look at the numbers here. Now, like I said, this would be listed much better. But for right now, I'm just kind of showing you live here how we do it. So let's go to our, we've got our torque here. We've got our thrust here. So let's look at our thrust. Okay, so on our 4S, our thrust was 4 grams at 1050, and it took us 0.11 amps. I mean, this is kind of insignificant. Let's go to where we're at, like 1400. Okay, so we're going to compare these two, right? So let's do a comparison of this one, and we'll do a comparison of this one here. Okay, let's start with those. All right, so on a 4S, we had a thrust of 218 grams, and on a 5S, we had a thrust of 383 grams. All right, now it took us 5 amps to get there on the 5S, and it took us 3 amps to get there. I'm rounding down, 3 amps, right? So you have to now look at this and you have to say, okay, so to achieve 383 grams of thrust on a 4S, I have to be somewhere around here. Now look at this. To be that, you have to spend, or I say spend, you have to utilize or burn up almost 7 amps to do what you could do in 5 amps here. This is where it starts becoming an issue of being efficient, and are you running efficient, and are you getting the most out of it, okay? So what we want to do is we want to find our target. Now in this case, we said that our target was going to be 400 grams at 8 to 1. Well, we realized that the 4S isn't really going to get us there. So let's do a 6 to 1. A 6 to 1 would mean that 400 grams would need 2,400 grams of thrust divided by 4 motors, right? So let's just make our goal equals 2,400 grams of thrust, right? And that means it's 2,400 divided by 4, right? Which equals 600, okay? So we need to get 600 grams of thrust out of our motor, okay? And each motor times 4 then. So where can we find 600 grams of thrust? Well, we can find it here at barely above 50% throttle, or we can find it here at 80% throttle, right? Now look at this though. The difference is, and I'm gonna set our goal as being, I'm gonna make it orange. Okay, so we're gonna make this orange. Okay, so let's do orange here, and then I'm gonna do it here as well. Whoops, that's not right though. I needed, we were trying to get to 600, so 600 we're gonna say is gonna be right here. Okay, so compare these two now. So to get a 6 to 1 thrust to weight ratio, I'm going to be using 10 amps. This is my amp column here. And I'm going to be using 20% more amps here. I'm going to be using actually almost 30% more amps at almost 13 amps. So 10 versus 13, it's fair to round up a little bit, okay? And so at this point, I'm going to be able to achieve this, and I'm going to be able to run 30% less taxing on my ESCs, which then interprets into being longer flight time, right? Okay, I know this is getting boring, guys. I'm just trying to explain it because this is what we're going to get to now as we start making more quads. We want to start becoming more efficient and helping the racers achieve what they want and guys who are flying a long time. So looking at this one, we would easily say that we can achieve our 6 to 1 here much more efficient, okay? And so if we want to look at our efficiency rating, you can even tell that even at this point, we're still running extremely efficient on our overall efficiency here. And our vibrations are lower. Now, I don't know about our temp. Let me see our temp. And our temp is actually a little bit lower, all right? To almost equal this out, we have to be running at 1,600 or 60%. And at 60%, that's going to give us almost 700 grams of thrust. We don't even hit that here, all right? So, I mean, look how much more thrust we get here. So if remember we were talking about 8 to 1, 8 to 1 was 3,200, which means all I need to do is get 800 grams of thrust. That's right here. All right. Now, if I want to run 10 to 1, that's 4,000 grams of thrust. I'm still below my 80% with the 5S battery. So same motor, same everything, just a different battery, and I can do it. Now, okay, so I'm going to stop the video. Sorry, my cameras, I got to push the buttons here. This is extremely boring. I get it, okay? But if you're into math like I am and you love numbers like I do, this is like gold to me, because I can take a quad now, and if I get the weight and I have my formulas done right and I do everything, I can tell you, you tell me how fast you want to go, or basically how long you need to fly in a race, or you tell me how long you need to fly during a freestyle, or you tell me how long you need to hover while you're taking pictures, whatever it may be. All these things can be factored from this, and then we take in your weight, we take in everything else. We find out where your average is for flying by reviewing your black box, and all of a sudden you've got a quad that is like amazing, right? It's like tuning a car and dynoing a car, but it's for a quad. So this is the information. Again, I'm gonna put this back here for you, so you can check this out right here. This is the kind of stuff you're gonna start seeing, and we're gonna do 10 props like this because we're gonna compare all the batteries with all the props to find out which one runs the best at any given point. All right, guys, look, I hope that helps. I know this is kind of boring, like I said, and I can get on yapping for a while, but it is important to me. Hold on, I need to edit something here real quick. Sorry, I need to put this at the top. Bear with me a second. Why isn't that working? I have no idea. Okay, let me just cancel it. Okay, anyways, I gotta set up all this crap. Okay, look, if you have any questions, guys, please go to our Facebook page. That's what I was hoping for, was I had the link, but I can't get it to post right now. So it's facebook.com/groups/Cyclone FPV. Or you can just go to this one, which I'll make pop up. And that's our Cyclone FPV page. And from there, you can get to our groups. As always, also, please subscribe to our YouTube channel. It's really helpful, and I appreciate it. And other than that, I got really nothing else to say. It's been kind of a long jibber jabber anyway. So listen, God bless, be safe, spend time with your family, guys. You don't know how much time you got left, so make the most of it, please. There's always time for flying. Anyways, we're gonna have some more data, okay? So I'll talk to you guys soon, and please don't haze me on how boring this was, okay? I know, trust me, I get it. Talk to you soon. Bye.